Welcome back, Chemistry 30. So this is the second video in EC1.6. So I left you with these ones. So we'll take a look at seeing whether the way these equations are set up, are they going to be spontaneous or not? So we kind of figure what's being reduced and oxidized initially. So from what we've done previously, we can check the I and we can check the copper here. So copper is going from +2 down to 0. So that's going to be reduced, going from +2 to 0, that's reduction. So that's going to be our reduction area there. So let's write that down, reduction. And of course, if this was an electrochemical cell, that's where the cathode would be. So copper 2 plus. I know I'm going to have to add some electrons in order to get it to copper solid. And if I look over here, we've looked at this one before. Copper 2 plus going to copper solid. It's right here, right here. So 1 to 1 is the ratio, 2 electrons for every 1 copper. That's going to give us plus 0.37, I believe. I think when I did this earlier, I chose the wrong one, I think, in my book, but let's see here, let me just double check. So copper 2 plus going to copper solid. So yes, copper 2 plus going to copper solid, that should be plus 0.337. Indeed. So we're gonna have to, let's look at that. So plus 2 electrons, but hey, you can see here I multiply everything by 5. So 5, and then 2 times 5 is 10 electrons, and then 5. And again, this stays the same though. So my reduction potential will be, let's see. All right. So yeah, that works out to be plus 0.337. Okay, and yeah, so the other one must be oxidation, and of course that would regularly be where the anode is. Let's see what's going on here. So yes, so we have iodine, oxidation number of 0, going to over here the iodate ion. Now oxide is 2 negative times 3 is -6 negative. Right here, let's do this right. -2 times 6 is negative 2 times 3 is -6. I need to end up with a charge of -1 here. +5, +5. Oh yeah, it's going from 0 to +5. That's definitely oxidation. Now, let's look up the right equation here. Iodine going to iodate. Iodine going to iodate. So that would be here. So again, iodine going to iodate. It would release electron. Of course, this is written reverse because it's written as a reduction. So hey, that's where the rest of the compounds are. Iodine plus water. Iodine plus 6 H2Os gives us 2 iodates, 2 H pluses, and 10 electrons. 2 iodates, 2 H pluses, and 2 electrons. So hey, that all works out great. We just have to make sure to draw it the right way. So we have iodine plus the 6 H2Os gives us, did I do that right? Yes, I did. So 2 iodate ions plus 12 H pluses, and then I had what there? Yes, 10 electrons, matching the gain in 10 electrons there. And if I go back to here, let's read what that is. Plus 1.195. So that's plus 1.195 volts. There we go. Now it's easy peasy. Now so we do a check here. So the reduction or the cathode should be more positive than the oxidation, and 0.327, 1.195. So we can see this isn't going to work. But let's show the equation here anyway. So the reduction, so at the cathode, that's where we have reduction. I was going to write cathode there because I'm so used to doing that. And then the reduction potential where there's oxidation. Hopefully by this point we have it nailed that reduction is at the cathode and oxidation is at the anode. So let's see here, my reduction is plus 0.337 volts minus plus 1.195 volts. Minus a positive. And let's see what we get here when we put that in our calculator. So we get negative 0.858 volts. So I can say our little statement here, since the standard potential is of the cell or of the reaction is negative, the reaction is non-spontaneous. There we go. Why don't you try the next one? Just pause the video. You try the next one. This one's pretty easy to figure out what's reduced and what's oxidized. Use that little table and go from there. All right, hopefully you had some time to work through that. So you can see here mercury going from +2 to 0. That's definitely going to be reduction, getting more negative, right? Then here we have -1 going to 0. We're getting more positive, so that's where the oxidation is going to be occurring. So we can set this all up. Let's set up the reduction here. I'm not going to write cathode and anode this time. So reduction, so mercury, Hg2+ is going to be going to Hg. So there should be a +2 electrons there. Let's double check. Right here, so 2 mercury plus 2 electrons, giving us liquid mercury, which is what we have, and that's going to be plus 0.789. So E reduction potential, and then plus my 2 electrons. And over here, iodine, I minus going to I2. Oh, it's right below here. I minus going to I2, releasing 2 electrons. That's going to give me a value of plus 0.536. So that's what we have. And oops, just take a look here. So that's, let's see, that's Hg2+. I think I looked off the value of Hg2+. Let's see here. Hg2+. Oh, I read the wrong one. So Hg2+. Where are we? Here we are. Yes, careful using this chart. Hg2+ going to Hg. Hg2+ going to Hg. So yes, be sure to read the right one. That's going to be plus 0.854. So plus 0.854. Sorry about that, gang. Good thing I caught that. And let's look at the oxidation area. So we looked at that. So the 2 I's, negative, going to I2 plus 2 electrons. And the reduction potential there, what was it here? I forget. Plus 0.536. So again, the reduction number should be more positive than the oxidation number for this to be spontaneous, and there it is. It is. Oops. Reduction potential where there's oxidation. So we have plus, where's our reduction? There it is. Plus 0.854 minus plus 0.536. Oops, 854 minus 0.536. Oops, don't need a bracket there. Trying so hard not to be messy here. Plus 0.318 volts. Therefore, since E is positive, the reaction is spontaneous. Ooh, brain freeze. Spontaneous. Woohoo. All right, there's one more left. I guess I should move this up so you can actually see what I'm writing. So one more left. I'm going to stop the video here. So the third video will have the solution for this one. See, so here, the manganese, you can figure that out. And then I'm thinking, check the S out here. It's the sulfurous acid. See if you can figure that one out, and then we'll see how you do it in the next video.